my dear students, let's continue module 8. In this video, inshallah, we'll continue module 8. So module 8 actually has the part of transformations. The first thing is translation, is when you move something. The second thing, reflection, and it can be either across the x-axis or the y-axis. So translation is to move the shape itself. Reflection is to mirror it. To mirror across the x-axis. In this case, we change the y. Across the x-axis, we change the y. If it's across the y-axis, we change. If it's across the y-axis, we change the x. The last two transformations is either rotation or dilation, and we will talk about them in details. In the translation part, here's my main rule. You have the point or the original image. We always go from P to P prime. This is how we differentiate between the original and the image. The image always have a prime, and if I have another image, it will be double prime. Very good. So the original is P, P prime, P double prime, whatever the letter, P, A, but the prime differentiates the image. Very good. So if I said up or right, both are positive. Up 2 steps, so add 2 steps for the y. Up and down for the y. Down, so down 2 steps, so the y minus 2. Right and left, right is positive, left is negative. So right and left are actually affecting the x. So again, up positive, down y negative, y positive, and y negative. Right x positive, left x negative. So if I said right 2 steps, so x plus 2. If I said left 2 steps, so the x minus 2. For example, in this point he's asking ABCD is translated to trapezoid A prime, B prime, C prime, D prime. So the first step, I should know where is the original thing and where is the image. A, B, C, D, this is the original. Why? It doesn't have any dash, then it doesn't have any primes. So A prime, B prime, C prime, C prime, D prime, this is the image. Mr. Is the difference? Yes, we move from the original to the image. We should move from the original to the image. For example, from A to A prime. What happened on the y-axis? How many steps did we go down? Count. 1. Let's zoom in a little bit. Yes. 1, 2, 3, 4, 5, 6, 7, 8 steps down. And how many steps to the right? So again, I went down 8 steps. And how many steps to the right? Count. 1, 2, 3, 4, 5. I want to reach the A prime. So I went to the right 5 steps. Very good. So which one? Yes, we went 8 units down and 5 units to the right. Here it is, my answer. But Mr. If I did it with any other point, for example C, and I must go for, so I must go for C prime. So let's count together. 1, 2, 3, 4, 5, 6, 7, 8. 8 steps down. I went down also 8 steps. And to the right, how many steps? 1, 2, 3, 4, 5. I went to the right 5 steps from C to C prime, A to A prime, B to B prime, D to D prime. Any point to its image will give us the same translation things. Very good. Here, where is the image and where is the original? The one that doesn't have a prime is the original. So the N here, or the blue one here, is the original. We do not judge it by the colors. We judge by the letter itself. So N is the original. N prime is the image. Very good. So from M to M prime, count to the left. 1, 2, 3, 4, 5. I went 5 to the left. And how many steps up? 1. We stopped here. 1, 2. So we went up 2 steps. Very good. So again, we moved 5 to the left and 2 up. 5 to the left and 2 units up. Amazing. 56. The pre-image and the image of ABC are shown. Use coordinate notation to describe the translation. Again, from A to A prime. Let's count. 1, 2, 3. I went up 3 steps and 1, 2, 2 to the right. So 3 units up and 2 units to the right. 57. From H to H prime. From H to H prime. Count together. 1, 2, 3, 4, 5, 6. So I went up 6 steps. And how many steps to the left? 1, 2, 3, 4. I went 4 to the left. So 6 up and 4 to the left. Which one? Yes, B. Very good. 58. Translate the point. Negative 3, 4. Left 5 and up 1. Again, left and right affects the x. Up and down affects the y. Left is negative. So minus 5. X minus 5. Up is positive. So y plus 1. Very good. So again, subtract 5 from the x. Add 1 to the y. Minus 3 minus 5 is minus 8 or negative 8. 4 plus 1 is 5. So this is the correct answer. Again, what does a translation do to an image? It moves it. It moves it. It slides it. Very good. Shrink, dilation. And we call it reduction. When it gets smaller, it is a reduction or dilation. Dilation is divided into 2 parts, and we'll talk about it in details. Mirroring, reflection, turn, rotation. Write the rule for the translation. Translate 3 up and down affects the y. So y plus 3. And 2 right affects the x. To the right, positive 2. So x plus 2, y plus 3, yes. Bravo. 61. What does this transformation say to do? xy, x becomes as it is. So it didn't move to the right, or neither to the right nor to the left. But it went up 4 steps. It slides up 4 steps. Because he said y plus 4. Very good. Reflection. Reflection either across the x-axis, or across the y-axis, or across a certain line. So if it's across the x-axis, this means we should change the sign of the y. If it's across the y-axis, we will change the x, and here we will see how we will do it. Now, identify the transformation from ABC to A prime, B prime, C prime. So here is the original. In any image in this part, you should know where's the original and where is the image. Very good. You will notice that it is mirrored. Look, B is 1 step away, B prime is 1 step away. C is 1 step away, C prime is 1 step away. And the same thing with A and A prime. So it is the mirror of it. What is my mirror? The x-axis is the mirror. So we will say that it is reflection across the x-axis. Here, where is the original? Here it is. This is the original. And the second thing here is the image. Look also, you will find that A, B, C, D, A, B, C, D. Take care in this part. Is it reflected? No. It is not reflection. Why? Here I said reflection. Yes, B, B prime. C, C prime. This is reflection. Both of them are close to the x-axis. And then A is far away. Here, you will notice that A prime with A, both of them are not the same distance from the y, so we cannot say it is reflection across the y-axis. So what happened? A moved to A prime, D moved to D prime, C moved to C prime. So actually it is translation. The same question, let's discuss this, invest more time in this question. If I have x and y axes like this, and also two rectangles, sorry. Here is the first rectangle, and here is the second rectangle, okay? Both of them are the same. And I have A, B, C, D. And here is A prime, B prime, C prime, D prime. In this case, is it translation or reflection? No. Yes, this case is a reflection. Why? Look. Reflection across the y-axis. This is my mirror, the y-axis. And B is the same space or the same distance from the y-axis. A and A prime are also close though to the y-axis. D and D prime are far. C and C prime are far. So they are mirroring each other. So we call it as reflection across the y-axis. Clear? So again, as long as they are in the same order, A, B, C, D, A, B, C, D, this is translation. It just moved without anything happened. Translation. But here, A, B, C, D, it is reflected the other side. A, B, C, D, it went. You notice that it acts like a mirror. A are close to the y-axis. C and D are far away. So this is reflection. The graph of PQR and its image P prime, Q prime, R prime. After, okay, so PQR, what happened to it to the other side? It reflected. Excellent. R are close, P are close, but reflection across what? This is the x-axis here. And what about this line? 1, 2, 3, 4. This is x equal 4. This line is x equal 4. So this is reflection across x equal 4. Reflection across x equal 4. The graph of the triangle ABCD and its image A prime, B prime, C prime, D prime. What happened here? Yes, reflection. You will find that it's a mirror of the original thing. This is the original, yes. And where is the image? Here is the image. Very good. A prime, D prime. Both of them are close to the x-axis. 2 steps away, 2 steps away. So this is just reflection across the x axis. Very good. Here he said reflection across the x-axis, and in 67 he said reflect across the y-axis. So simply, when he says reflect across the x-axis, we change y. When he says reflect across the y-axis, we change x. So let's do it together. Here I have A, B, C, D. So A prime becomes, it was 1 and 3, correct? When I change the y, it becomes 1 and -3. B prime, it was 4 and 5. I will change the y. I will change also the y, so it is 4 and -5. C prime, where is the y? The 6, change it. So it becomes -2, -6. D prime, -3 and -4. -3 as it is, and I just change it. The y becomes -4. So which one is the correct answer? Which one has -3, -5, -6, -3, -5, -6, -4? Yes, the 1 is as it is, the 4 as it is, negative 2 as it is, and negative 3 as it is. Yes, here's the correct answer. Number 67, he says change the x. I will just change the x. So how it becomes? W prime is 3, negative 2, x prime, which is 5, negative 2, y prime becomes negative 1 will be 1 and 2, z prime is 0 and 2. There is nothing called negative 0, okay? Which one is correct? 3, negative 2, 5, negative 2. Yes, this one, 3, negative 2, 5, negative 2. But here is 1 and 2, so this is not correct. So what else? 3, negative 2, 5, negative 2, 1 and 2, 0 and 2. Yes, C, excellent. Very good. Apply the following rule to the point negative 5 and 6. X and Y becomes Y and negative 6. Actually, this is rotation. This is related to the rotation. Rotation, before I solve this question, let's see the rules here. Rotation coordinate rules. 90 degrees clockwise or 270 counterclockwise, both are the same. Okay? So, why are they the same? This is the question. Clockwise, here's clockwise, and this is counterclockwise. Clockwise with the clock direction, counterclockwise opposite to the clock direction. Very good. So, when he says 90 clockwise, this means I always start with from the 0. So 90 clockwise, this is 90, 180, 270, 360. Each quadrant is 90 degrees. So again, 90 clockwise with the clock direction. It will be the same like 270 counterclockwise. This is counterclockwise. So 90, 180, 270 counterclockwise, you will reach the same point. So if you said clockwise 90 degrees, it will be the same like 270 counterclockwise. So both here are the same. And also, if you noticed here in the third rule, 90 counter is the same like 270 clockwise. Okay, so they have the same rule. 180 clockwise or counterclockwise, it doesn't matter. In the 180, both will be the same. Why? Let's see. If I am here at 0 and I moved 180 clockwise, 180 counterclockwise will also reach the same point. So they have the same rule, negative y and x. Okay, so let's continue solving here. In 68, rotation, he just says apply the rule, negative 5 and 6. I want it to rotate y and negative 6. So again, negative 5 and 6. When you switch them, it becomes 6 and negative 5. And he says put a negative for the second. This means change the sign of the second. So it becomes 6 and 5. Very good. Here, 1 and 2 becomes negative 1 and 2. What happened? The same order, but we changed the x. 3, 3. The same order, we changed the x. Same order, but we changed just the x. When we change the x, this means it is reflection across, who remembers? Across the y-axis. Yes. Amazing job. If I changed the y, it would be reflection across the x-axis. Very good. Here, he says, translation from A to D. What happened? It rotated. How many quadrants? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. It moved one quadrant from 1 to 4. So if I moved clockwise, this is 90 degrees clockwise. If he said counterclockwise, this would be 90 counter, 180 counter, 270 counter. So it is also 270 counter. What is the choices that you have? 90 clockwise, so yes, it's correct. It moved from A to D 90 degrees clockwise with the clock direction. Triangle C is rotated 180 clockwise. Here's triangle C, and it rotated 180 clockwise. So 90, 180, where it becomes A. Very good. What is the angle of the clockwise rotation? How it rotated? It was here at A. When I rotated 90 degrees clockwise, what happens to it? It will be A prime. It will be tilted like this. Okay? If you rotate it, if you put a tracing paper, if you have a tracing paper, and you draw on the tracing paper this shape, when you rotate the tracing paper, it will actually appear in this way. So this is 90 degrees clockwise. Here in 73, if we were to rotate A, B, C, D 180 degrees about the origin, what would the coordinate of A prime be? Where it would be? Again, X and Y. To rotate it 180 degrees, it becomes negative X, negative Y. Where is A now? A is at 3 and 5. When you rotate it 180, negative 3, negative 5. You just change the sign, so it becomes negative 3, negative 5. Mister, in 72, if I don't have a tracing paper, how do I know what rotation happened? What is the point A? 3 and 5. It is at X is 3 and Y is 5. And where is A prime? 5 and negative 3. Immediately when you find switching in the numbers, this means 90 or 270. So this is 90 degrees. If the negative sign is put, or you change the sign of the second thing, this means clockwise or counterclockwise. Remember the rule. When you change the sign of the second, this means clockwise. Change the sign of the second, clockwise. So this is 90 degrees clockwise. Very good. So 74. Identify the rotation from T, U, V to T prime, U prime, V prime. Here is the common T. As long as the T is common between the two images, so this is rotation about the point T, not about the origin. Very good. And what happened? T, U, V, when I rotate it, when I find it the other side, is it 90 degrees counterclock or 180? 180, so the point U would be here. Why? 90, 180. But do you find the U here? No, so it is not 180. It is 90 counterclockwise. CC means counterclockwise. How do you know? Let's see together. Sorry, let's do this again. Again, the T is common, so it's about the point T. So we will cross these out. The point U, let's focus on the point U. If he just moved to the next quadrant, so it is 90, but he moved another 90, so it is 180. Now, to make sure, let's follow the point V. Here's the point V. If I moved 90 only, it will be 90 clockwise, it will be in the next quadrant here, but it moved another 90, which total is 180. So the V prime is in the next quadrant, not the next, the one after it. So 90, 90 again, 180. Very good. 75. Identify the rotation from A, B, C to A prime, B prime, C prime. Again, the common point is A, so it is not about the origin. We are rotating about the point A. Again, B moved to the next quadrant. This is clockwise or counterclockwise. It is opposite to the clock direction, so 90 degrees counterclockwise. Very good. Let's check the point C. Again, it moved from C to C prime. Only it moved one quadrant. We have four quadrants. Four quadrants. 1, 2, 3, 4. It moved from quadrant 4 to quadrant 1. From quadrant 4 to quadrant 1. So it just moved 90 degrees. Very good. A counterclockwise rotation of 90 degrees is equivalent to how many degrees of rotation clockwise? 90 counter is the same like 270 clockwise, and 270 counter is equal to 90 clockwise. The polygon that has these points made a rotation 270 about the origin. 270 clockwise is the same like 90 counter. What is the rule for the 90 counter? Let's remember. X and Y becomes negative Y and X. This is the counter. So we need to switch the points, and change the sign of the first. So E prime becomes negative 3 and 4. I just switched. Change the sign of the first, so it becomes 3 and 4. Which one here is 3 and 4? Yes, either A or B. So we will cross out these. Let's see F prime. Switch them, becomes negative 4 and 2. Change the sign of the first, so it becomes 4 and 2. Yes, so the correct answer is the first one. Triangle JKL has vertices 3, 1, 2, negative 1, and 1, 2. After rotation counterclockwise of 90. 90 counter, the same thing here. X and Y becomes negative Y and X. So 3 and 1, J prime becomes 1 and 3. Switch the signs, switch the numbers, and change the sign of the first. This is J prime, negative 1 and 3. Which one? Either B or D. So let's see the K. K prime, switch negative 1 and 2. Change the sign of the first, so it becomes 1 and 2. Yes, so this is the correct answer. E prime, it was for negative 3 when you rotate 180. When you rotate 180, what is the rule? We change the sign of both. Negative X, negative Y. So 4 and 3, it becomes 4 and negative 3, it becomes negative 4. The 4 becomes negative, and the negative 3 becomes positive 3. So negative 4 and 3, which one? Yes, B. Excellent. Number 80. Use coordinate notation to describe the rotation, then determine the angle of rotation. Here, from E to E prime, we have two ways. Either the clockwise direction, 90, 180, 270. So it is either 270 clockwise, or from E to E prime, counterclockwise, opposite to the clock direction, it would be 90 counter. Which choice do you have? 270 clockwise or 90 counter? Yes, I have 270 clockwise. Here, 81 again, from A to A prime. Let's see together. We moved 90 degrees to the right. We rotated, actually not moved, we rotated 90 degrees to the right. So 90 degrees clockwise. Here it is. Can I check it with B? Yes. From B to B prime, what happened? It rotated. 90 degrees clockwise. Dilation is either enlargement or reduction. When it gets bigger, enlargement. When it gets smaller, we call it reduction. Again, from P to P prime. This is the original, and P prime is the image. Dilate by a scale factor of 3. Whenever the scale factor is greater than 1, enlargement. If the scale factor is less than 1 and greater than 0, this is reduction. So for example, scale factor 3 greater than 1, so it is enlargement. Mr. The scale factor here is half, it is less than 1, so it is reduction. Very good. So 336693, when you make the scale factor 3, you multiply everything by 3, so A prime is 3 times 3, 9, 9, 9. Where is 9, 9 here? Yes, here. So the answer is A. If I want to make sure 6, 6 multiplied by 3, 18. 6 multiplied by 3, 18 also. Very good. Scale factor half. So I'll multiply this point by half. Negative 10 times half becomes negative 5. Negative 6 times half. Half of 6 is 3. So it is negative 5, negative 3. Why did you pick this one, not this one? Because the scale factor doesn't change the signs. Negative 10, it becomes negative as it is. Negative 6, it is negative as it is. Very good. So here, from A to A prime, what happened? It got larger, so it is enlargement.